Today we'll continue with indices. We are going to step up our game by solving maybe a bit more high equations compared to the level we dealt with in the last class. So this is the first question we have. We are asked to simplify the cube root of 64a to the power of 3, then raised to the power of -1. Whenever you have a negative power, it means you are going to take the reciprocal of that number. So this is 1 all over the cube root of 64a to the power of 3 because of that negative power. So this is also the same thing as 1 over. Now the best way to tackle this is to know that 64 on its own means 4 to the power of 3. And we already have a to the power of 3 here, right? So now this becomes 1 all over cube root of the power of 3 here is common. Look at the power of 3, right? So the best way to do that is to factor out that 3. So we can call this 4a, then raised to the power of 3 because the power is common. So what do we do from here? This cube root and the roots, this power of 3, we cancel the cube root and the root, leaving us behind with just 1 over 4a. So this is the right answer, 1 over 4a. Okay, so let's take another one. If you look at question number 2, we have 3 to the power of n minus 1 multiplied by 27 and 81, as you can see here. Now the best way to tackle this problem is to ensure that all the bases are the same thing. Yeah, so already we have 3 to the power of n minus 1 multiplied by 27 can be split into 3 power 3. You know that 3 power 3 will give you 27, right? Then you have your power of n plus 1. Everything all over 81 can be written as 3 to the power of 4 because 3 times 3 times 3 into 4 places will give you 81. Then we have a power of what? N. Look at this power of n here, you write it. So this becomes 3 to the power of n minus 1 multiplied by 3 to the power of we times this 3 here. 3 times n is 3n, and 3 times 1 will give us 3 all over 3 to the power of 4n. In the numerator, because the bases are the same thing, you can add the powers. So we have 3 to the power of n minus 1 plus this power here, you add it, plus 3n plus 3 all over 3 to the power of 4n, right? So that becomes 3 to the power of n plus 3n is 4n, and minus 1 plus 3. Minus 1 plus 3 will give you 2, right? All over 3 to the power of 4n, isn't it? So that from here, when you have division, this is division line, you subtract the powers, because laws of indices tells us that once you have division, simply subtract the powers. So that becomes 3 power 4n plus 2, then minus this power of 4 here, minus 4n. And 4n minus 4n is 0. So we are left with just 3 to the power of 2. And 3 power 2 will give us 9. So the solution to the second problem is equal to 9, right? Now let's take a third one, because the more we solve this, the more you get to understand it. In the third one, we have 27 raised to the power of 1 over 3. I'll use a very nice method to solve this particular one. Seeing this 27 here, I can call 27 3 power 3 because 3 times 3 times 3 is 27. Then raised to a power of 1 over 3. We have a power of 1 over 3 here. Minus 8 is the same thing as 2 power 3 because 2 times 2 times 2 into 3 places will give us 8. Then raised to a power of 2 over 3. All over denominator. You know, when you have 16 here in this denominator, this 16, somebody can call 16 2 power 4. You are correct. Another person can call it 4 power 2. You are still correct. But which is the best one to call it? If I were you, I will not use this one. I will use this because there is a denominator of 4 here. When you write 2 to the power of 4 and you have a power of 2 over 4 again, it is best to use this because this 4 will now cancel this 4. Have you seen why I'm using this to represent 16? That is the best power to use, right? Then everything multiplied by 2. So this 3 will cancel this 3, leaving us behind with 3 power 1 minus this 3 will cancel this 3, leaving us behind with 2 power 2 over, already 4 has cancelled 4. We have 2 power 2 multiplied by what? 2, right? 3 power 1 means 3 minus 2 power 2 is 2 times 2, 4 over 2 power 2 again, 4 times 2. And 3 minus 4 is equal to negative 1 over 4 times 2 will give us what? 8. So the right solution to this is equal to negative 1 over 8. And that's the real solution, negative 1 over 8. So you've seen that solving problems like this is really not a difficult thing to do. But one thing you need to know in solving indices is that you have to first of all ensure that the bases are the same thing. Once the bases are the same thing, everything becomes easy for you. So bases are the same thing, then you connect the powers. So we'll stop in here and we'll share some questions with you to solve also to be sure you fully mastered it. Bye.